I'm R. Prabha, Assistant Professor in the Department of ECE, SNS College of Technology. In this video, we will discuss the topic on antenna measurements and introduction. So, antenna measurements are needed to establish the performance of an antenna like gain, pattern, polarization, and bandwidth. Antenna measurements are carried out using a test antenna in the receiving mode. The test antenna is affected due to reflections from the ground and nearby objects such as tall buildings, trees, and mountains. So, there are various requirements of antenna measurement. One is to verify the design, to control the quality, to analyze different parameters, to find analytical and statistical errors, to indicate actual performance, to adjust critical components and dimensions, and to calibrate and store data for different types of antenna. And the basic concept behind this antenna measurement is the most common antenna measurement is measure the radiation properties like directional pattern, gain, or phase pattern in the far field. The basic procedure in the far field measurement is to place a transmitting or receiving antenna at different locations with respect to the antenna under test, that is the reference antenna, and get a number of sample patterns. And to achieve different locations, antenna under test is rotated, and to ensure sharpness of the pattern, only one direct path should exist between the antenna under test and the source antenna. And the diagram represents how the antenna under test is located with respect to the source antenna in a coordinate systems. So in the diagram there is x, y, z coordinate. At the origin the antenna under test is located, and at a distance r from the antenna under test source antenna is there, and the distance between these two antennas are r, and there are two angles measured here. Theta is the polar angle and phi is the azimuth angle. And the important concept behind antenna measurement is reciprocity, and generally an antenna is a device which can be used for transmitting and also receiving, and there exists a reciprocal relationship between the transmitting and the receiving properties of the antenna, and the reciprocal relationship is very useful for antenna measurements, and this relationship allows us to obtain the characteristics of an antenna from transmitting test or receiving test, whichever is most convenient during measurement. And it is necessary to study two important consequences for antenna measurement. One is the transmitting and receiving patterns are same, and second one is the power flow is same in transmitting and receiving mode. And the reciprocal relationship following condition must be satisfied. The electromagnetic field, the EMF at the terminals of transmitting and receiving antennas should be of same frequency. The power flow should be equal to that of matched impedance. The medium should be linear, isotropic, and passive. And there are three main regions during antenna measurement. One is the region very close to antenna and is called as reactive near field region. The second region is next to reactive near field region and is called as radiating near field region, or also called as Fresnel region. And the region located far away from the antenna is called as far field region, or also called as Fraunhofer region. So this diagram indicates the three different regions, and close to antenna is reactive near field region, and the next is radiating near field region, and far above from the antenna there is a region called far field region. And the diagram indicates how the radiation takes place and the distance measurement, and above 2d square lambda distance the far field region exists. and most of the times the radiation pattern in the far field are desired. The measurement is done in the far field, and there are so many advantages in this far field measurement. One is the coupling and multiple reflections are least significant in the far field region. If a power pattern is required, only power measurement is needed, and at any point in the far field region the field pattern measurement is valid. And there is a disadvantage also in the far field measurement is that it requires large distance between the transmitting and receiving antennas, and the distance may increase to such an extent that the result of the measurement in the far field region suffers by atmospheric attenuation. And the reactive near field region is not used for antenna measurements because it is located too close to antenna under test, and the remaining choice for the antenna measurement is the measurement the radiating near field region. And this diagram represents the coordinate system for antenna measurement. The antenna is kept under test, is kept at the origin, and the spherical coordinate is chosen to take any antenna measurement or any antenna analysis. And because the radiation from the antenna is considered as a sphere, so a spherical coordinate system is used, and there are three coordinates, and the three elements are r, theta, phi. R is the distance, and theta is the polar angle, phi is the azimuth angle. And now the assessment, what is the need for antenna measurements. We know the antenna measurement need, and it is very important in antenna design, and reciprocity is a very important principle in antenna measurement. And near field far field measurement, we can easily differentiate. Near field there are two cases. One is reactive near field, which is very close to the antenna, and radiating near field, and which is just some distance from the antenna. And far field measurement, if the distance from the antenna under test to the source antenna is greater than 2d squared by lambda, the measurement is called as far field measurement. Thank you.